Welcome back to my channel. In my previous episode, we take a look at fundamental quantities and units and how they can ask you, or let's say, and the area in which question is always asked often in JAMB. Today, we'll be looking at another topic, which is derived quantities and units. What are you expected to know about these quantities? We'll be getting to know this at the end of this class. If you are new to my channel, please support me by subscribing and liking my video. Thank you. Let's get back to this class. Derived quantities. In my last video, I said physical quantities are either classified as either fundamental or derived. Derived quantities are quantities that are formed from the combination of two or more fundamental quantities. Majorly, all quantities in physics are classified as derived quantities, just with the exception of the few ones listed in my previous video. Don't forget that in my previous video, I said we can only have 7 fundamental quantities in physics. That means, with the exception of all these 7 fundamental quantities, any other quantities are all derived quantities. So please take note of that. In case you see something of such in your exam, that which of the following quantity is a derived quantity? The first thing I need to do is to pick out among the quantities the one that is a fundamental quantity. If you know the 7 fundamental quantities very well, then any other quantity there is derived quantity. Are we together? Now, these examples of derived quantities that we have are velocity, area, force, acceleration, etc. These are the examples of derived quantities that we have in physics. They are more than that. Don't forget I said it earlier. They are more than this. Majorly, most of them, they are derived quantities. Now, your knowledge is still going to be tested on the unit of these derived quantities. Don't forget I said derived quantities are quantities that are formed from the combination of 2 or more fundamental quantities. Likewise, the same thing, the unit that is used to measure derived quantities are also formed from the combination of 2 or more derived fundamental units. Now, note, we have 2 units that can be given to derived quantities. That means the unit of derived quantities are 2. We have the normal units and we have the derived units. The normal unit is the unit that is given to that derived quantity in honor of the scientists that make research or that did a great work on the quantity. For example, we know that force is an example. Force has 2 units. Majorly, students believe that the unit of force is Newton. That is correct. Unit of force is Newton, but this Newton is the normal unit of force. Now, Newton is the name of scientist, which is Isaac Newton. So this is the normal unit of force. This force also has its own derived units. The derived unit of force is gotten from its formula. For example, we know that force equals to mass times acceleration. Mass is a fundamental quantity which can be measured in kilogram. So, my force should be kilogram. Acceleration is a derived quantity. But acceleration is formed from the combination of velocity and time. Why? Because acceleration is the rate of change of velocity. So the unit of acceleration is meter per second square. So that means kilogram meter per second square is the derived unit of force, while Newton is the normal unit of force. This is number 1. Another thing I want you to know, another example that I might have in this case is work. Work done. We said work is always done when there is energy. And we said the work done is the force applied. The work is done on the body when a force is applied on the body to move the body in the direction of the force. Work done also has its own normal unit and derived. Normal unit of work done is joule, which is given, the name joule is given to the units in honor of the scientists that make a great work on it, which is Prescott Joule. Now, the derived unit of work is now equals to force times distance, which is kilogram meter per second squared, that is the unit of force, times meter, which is going to give us kilogram meter times meter will give me meter squared second squared. This is the derived units of work. That is that for that. Now, your knowledge is also going to be tested. Sorry, your knowledge will be tested on equivalence. That means equivalent units. When I said equivalent unit, simply means the relationship that is found between a normal unit and the derived units. Sometimes you'll be given a question. Let me give you an instance. An instance is that which of the following units is equivalent to kilogram meter per second? How do we work out this? Whenever they said which of the units is equivalent, you are going to be given a derived unit. They now want you to find the equivalent of this derived unit in the normal unit. That means, how can I write this derived unit in the normal unit to know the quantities that is having this unit? That is what we call equivalence. Now, for example, we said which of the following, the quantity, which of the following units is equivalent to kilogram meter per second. Before I talk about this, please let me use this example. You see, kilogram meter per second square here is equivalent to Newton. Likewise, kilogram meter square per second square is equivalent to what? Joule. Are we together? Now, the unit that is not equivalent to kilogram meter per second square per second here, how do we go about that? You don't know, we are just given different units. You can go in this way. Your kilogram is what? The unit of mass. Why? If I cross-check this is meter per second. Meter per second is the unit of velocity. I will put this simply means mass times velocity. Don't forget that the product of mass and velocity is momentum. Momentum is the product of the mass of the body and its velocity. So therefore, according to Newton's second law of motion, we believe that Ft, which is impulse, is equals to m change in velocity, which is momentum. What does that mean? I am talking about that. What I'm trying to is that momentum is what mv minus u all together. Why this one is this thing is what ft. That means momentum, which is change momentum, is equals to impulse. So if this thing is mass times velocity, which is momentum, right? That means this mv can be equivalent to the unit of force times time. Impulse is force times time, and the unit is Newton seconds. Force in Newton, time in seconds. Are we together? Now, mass times velocity, which is this unit, is equivalent to Newton seconds. That is the unit that is equivalent to. Sometime they will give you. Which of the following quantities has equivalent units with power, for instance? Or which of the following quantities has equivalent units with momentum? Now, momentum will have equivalent unit with impulse. Another great example is that watts, for example. We know that power is measured in watts. Question might be asked in this way, that which of the following formula is related to watts? They didn't tell us that it's power. They asked which of the following formula is the same thing as watts. Now note something. Let me remove this for you. Not something that you can easily answer this kind of question, that which of following formula is related to what. The first thing is that what is the formula, or let me say it is the units of power. Now, do you know that power itself is equal to work done by a body, all over the time taken to do the work. That means my work done on the body can be related as force times distance all over time. That is, work done over time, if it is in your option, work done over time is a formula related to what? That is number one. Also, from this work done over time, we can derive another formula that is related to what? Which is from here, I can say force times distance over time. Distance over time is velocity. It simply means force times velocity is also power. So, force times velocity will also have the same unit as what? Also, we can also have its work done by it. That is also power in an electrical devices. So, that means, do you know that power is also equals to IV? Now, IV is also another formula that will be related to watts. Please note that. Also, from this IV, we knew that voltage equals to current times resistance. Then from here, power can also be related to current square times resistance. This P is also related to what? Watts. Also, P can also be equal to V squared over R, which is also related to watts. So you can be asked a question like that. Which of the following formulas are related to watts? That means, what they are trying to ask is that what? Which of the following formula will have the units as what? Since you know that unit of watt is simply the units of power, so you can easily find out the relationship. The first is work done over time. The second is force times velocity, which is still the same thing as the formula for power. Please get your pen and your book. Jot down these important derived quantities. I've given you in the simplified way that you don't even need to cram anything to understand the question asking from you. Are we together? Now, thank you. Thanks for watching this episode. Please subscribe to my channel and like my video for more content of this kind. Thank you.